There's a light bulb in a fire station in Livermore, California that has been burning continuously since 1901. 125 years. It is on the internet right now. There's a live webcam pointed at it. It runs on the same electricity grid as your house, made with the same basic principle as every bulb ever sold. So how does that bulb last over a century while the LED bulbs in your kitchen die after 2 or 3 years? The answer is not the LED. The LED chip inside every bulb in your house is rated to last 50,000 to 100,000 hours. That is 40 to 90 years of normal use. The chip is not what fails. What fails is a single electrolytic capacitor, about 30 cents wholesale, smaller than a pencil eraser, soldered onto the driver circuit board hidden inside the base of every LED bulb. When that capacitor dies, the bulb dies. The chip is fine. The bulb gets thrown away. There are 4 things you can do today with bulbs you already own that will make them last 3 to 5 times longer. None of them require tools. The first one is the simplest, and almost everyone is doing it wrong. That capacitor I just mentioned has one enemy: heat. Electrolytic capacitors contain a liquid electrolyte that slowly dries out, and the rate at which it dries doubles for every 10 degrees Celsius of additional temperature. Engineers call this the 10-degree rule. An LED running at 85 degrees lasts 50,000 hours. The same LED running at 95 degrees lasts 25,000. Same chip, same bulb, half the life. Now look at your ceiling. If your bulbs are screwed into a fixture pointing down, the base of the bulb, where the driver circuit and the capacitor live, is on top. Heat rises. The hottest part of the bulb is exactly where the most heat-sensitive component is. You are roasting the capacitor every time you turn the light on. Flip the math. Bulbs installed base down, like in a table lamp or a wall sconce. Let heat escape past the driver and out the top. The capacitor stays cooler. The bulb lasts longer. Take inventory of every ceiling fixture in your house. The ones pointing down are killing your bulbs. Stay with me, because the second fix is even more important and almost everybody violates it. Look at the package of an LED bulb the next time you're at the store. There will be a tiny line of fine print, often on the bottom edge, that says, "Not for use in totally enclosed fixtures." That phrase looks like a legal disclaimer. It is not. It is a warning. An enclosed fixture. The glass dome lights in bathrooms, hallway ceiling fixtures with a globe over them, recessed cans with sealed trim, traps heat around the driver circuit. The temperature inside one of these fixtures can climb 30 degrees higher than the room around it. Remember the 10-degree rule. 30 degrees of additional heat means roughly 1/8 the lifespan. A bulb rated to last 15 years will fail in 2. Look up at every enclosed fixture in your house. If the bulbs in there are not specifically labeled enclosed rated, you are paying every 2 years for what should be a 15-year part. The enclosed rated versions cost about $1 more and are built with better heat dissipation. They are the only bulbs that should ever go into a sealed fixture. There's a third trick almost nobody knows, and it changes the math of buying bulbs entirely. Underdrive them. Every LED chip has a maximum current it can handle, and manufacturers push the chip as close to that limit as they can to squeeze maximum brightness from minimum chip area, because chip area is the most expensive part of the bulb. A chip running at 100% of its rated current generates the most heat and dies the fastest. The same chip running at 50% of rated current produces about 65% of the brightness, but lasts roughly 4 times longer. You can take advantage of this without modifying anything. Buy a bulb rated for a higher wattage equivalent than you actually need. If your fixture needs the brightness of a 60-watt incandescent, buy the LED equivalent of 100 watts and put it on a dimmer set to 70%. The chip runs cool. The driver runs cool. The capacitor lasts. You get the same light output for years longer. Commercial buildings have done this for decades. It is the reason warehouse lights last 20 years and your kitchen bulbs do not. Now here is the part that makes this whole story make sense. In 2014, Philips designed a special LED bulb for the city of Dubai under a partnership with the United Arab Emirates government. The specification was simple: maximum efficiency, maximum lifespan, no compromises for cost. The result is called the Dubai lamp. It uses about 3 times as many tiny LED chips as a normal bulb, each one running at a fraction of its rated current. The driver electronics are mounted on a separate board with proper heat dissipation. There is no enclosed plastic dome trapping heat. The bulbs are rated for 60,000 hours of operation, and they consume 1/3 the electricity of a comparable bulb. They are sold only inside the UAE. Philips will not sell them in North America or Europe. An electrical engineer named Big Clive tore one apart on camera and confirmed every claim. The technology to make a bulb that lasts 25 years exists. It has existed for a decade. It is just not what gets put on the shelves at your local store. There is one more thing on every LED bulb that is quietly costing you money even when the bulb still works. Lumen Depreciation. Every LED dims as it ages, and the industry standard for measuring lifespan is something called the L70 rating. L70 is the point at which a bulb has lost 30% of its original brightness. That is what manufacturers count as the end of useful life. So when the package says 50,000 hours, what they actually mean is the bulb will still technically be glowing at 50,000 hours, but it will only be putting out 70% of the light it had on day one. You will not notice the dimming because it happens slowly, but you will notice your kitchen feeling darker over the years and assume your eyes are getting worse. The fix is the same as everything else in this video. Run the bulb cooler in a base-down fixture, never enclosed, slightly underdriven on a dimmer, and the dimming slows down dramatically. The phosphor coating that converts blue light to white light degrades from heat just like the capacitor does. Cool bulb, slow dimming. Hot bulb, fast dimming. Here is the final piece that ties the Centennial Light back to your kitchen. That bulb in Livermore, burning since 1901, does not run at full power. It is rated for 60 watts and operates at about 4. The filament is barely glowing. It produces almost no light by modern standards. But it has been on for over a century because nothing inside it is being stressed. Heat is the enemy of every electrical component ever made. Run anything cool and it lasts. Run it hot and it dies. Your LED bulbs follow the same physics. You cannot redesign them, but you can change where you put them, what fixture they go in, and how hard you push them. 3 changes. Same bulbs you already own, 3 to 5 times the lifespan. The chip was always going to last 100 years. The bulb just needs to be allowed to. If you are going to flip your enclosed fixtures after this, hit the like button and share with someone who replaces bulbs every other year. Take care, and I will see you in the next one.